And the second aspect to this is that even if security engineering teams are aware of the IAC tooling that's out there, they may not have the right processes in place, or those processes might be very manual. So even within Fugue's customer base, and when we talk to our customers and prospects, we hear about manual code reviews. We hear about little gating functions here and there that add up to a lot of time spent by cloud engineering, by developers, and by security working through these issues together. And then last but not least, even if you have these processes in place, because they're manual and because in many cases they're not automated and integrated into how developers and DevOps team work, that can really slow things down. And so the net result of that is that for many teams out there, security is a rate limiting factor. It's a bottleneck for how quickly you can actually take advantage of cloud and deliver applications and deliver workloads that your organizations and companies actually need. So, I started by saying that our goal is to help cloud teams move faster and focus on building what matters, right? In a secure fashion. So, what we believe in at Fugue is that security has to start as early as possible, and it has to be integrated into as many steps as possible across what we call the cloud development lifecycle. And so what you see here is we've simplified this a little bit, right? We've simplified it into 3 distinct steps. The first step is around development, right? This is where your developers and DevOps teams are working with Terraform, CloudFormation, Pulumi. There's a lot of great tooling out there in terms of programmatically defining infrastructure. And the second stage is around deployment. So great, now you have these IAC templates. Ideally, you check them from a security perspective, and then you can go ahead and deploy them, right, with your CI/CD systems. And then the last step that we have here, which is runtime, is when these cloud resources that you declared in your Terraform or CloudFormation templates are actually now live and actually running on the cloud. And so for us, this isn't just 3 linear steps. This is a continuous cycle, right? And so what we believe is that our platform and tooling needs to support all of the steps involved there. And so what Curtis is going to show you later is how Fugue and Regula, our open source tool, support you there. So whether it's pre-commit or as part of your pull request processes, as part of your Git workflows if you're a developer, or maybe right before you deploy any infrastructure as part of your CI/CD system, or maybe immediately after, right? Many of you might use a deployment model where you have dev, staging, and prod environments. Are you checking those dev and staging environments to make sure that things are in sync and that things are appropriately configured live? And then last but not least, making sure that when you have production environments in place, that you're continuously monitoring these from a security perspective. We're going to talk about how all of those 3 should work together. And we make the point here that we want every team to use the same policies across every step of that life cycle. And that's incredibly important because what we find sometimes is that you'll have a team that's more focused on infrastructure as code, running some checks that are defined in one way and with some set of tooling, and then a different team using a completely different set of tooling and different set of policies, checking what's running in runtime. And just making sure that those 2 actually work together can be very problematic and can be a huge time sink and also create security issues as well. So it's important that, again, every team should use the same policies at every stage of what we call the cloud development lifecycle. So this next slide here is probably review for most of you, right? So why does IAC security matter so much? I mean, the first thing is that you want to catch things as early as possible to reduce risk, right? This is the whole idea behind shifting left. The challenge here, of course, is that this puts a lot of onus on development teams and security teams to work well together, right? And that second point is small misconfigurations become large attack surfaces. So one of the benefits of using infrastructure as code is that you can create a template and validate it once and use that to create hundreds or thousands of resources. But let's say that your company has a particular template that you use for VPCs or for Amazon S3 buckets. If there's a single misconfiguration in that template, that might find itself into hundreds of different cloud resources in different environments. And once that's in place, in some cases, these can be very difficult to fix. So let's say that you're using infrastructure as code for your RDS instances. If there's a misconfiguration there, you can't just go and fix it. You actually have to tear it down and create a new one, right? And so that can be very problematic for your application performance. And so again, big reason there why IAC security is so important is because some runtime issues just can't be fixed at runtime. You have to start all over again. And last but not least, right, we mentioned that we want teams to be able to move quickly and ship things much more often. And so if you get IAC security right, it saves your development teams and your security teams a lot of time. You can deliver business outcomes much faster. So with all that in mind, we're here to talk about Regula, which is Fugue's open source project. And it's a policy engine that checks infrastructure as code and cloud resources for security and compliance. And so I mentioned here that it's checking both IAC and cloud resources because Fugue, our security platform, actually relies on the Regula policy engine. And what this means for you is that if you're using Regula, and we'll get into this a lot more, if you're using Regula as your policy engine for checking infrastructure as code, you can take whatever policies you use there, whether they're written by Fugue or whether you've developed them yourself, and you can use those same policies to check your live cloud runtime resources as well. And that's a really important distinction. So in terms of how we built Regula and why we built it, right? One important thing for us is we wanted to leverage the power of Open Policy Agent. I think many of you might be familiar with OPA. It's a cloud native computing foundation project. It's very popular for folks in the Kubernetes ecosystem for checks there. And we've taken Open Policy Agent and built it and built a tool with Regula that's much more suited for checking cloud resources, whether it's for infrastructure as code or at cloud runtime. And so a key component for us was to make sure that it would, not only was it easy for Fugue to develop rules for Regula, but that it was also going to be easy for you as a community to write these rules. So Regula comes with a lot of tooling that make it easy to test and debug your own enterprise policies, which again can be applied across that cloud development lifecycle. Another aspect of this that we felt was very important is that, while many checks you might want to make on cloud resources are very simple, they might just be simple resource attributes. In a lot of cases, what you're checking for can get very complicated, right? You might be looking at IAM policy and how it relates to different resources. And so having a multi-resource type check can be very powerful and very important from a security perspective. And so that's something that Regula supports as well. And then lastly here, we wanted to make sure that we had a tool that could integrate very well with all the CI/CD tooling that's out there and with testing frameworks like CompTest. So if you're already part of the Open Policy Agent ecosystem, you're probably familiar with CompTest, which is a testing framework. And so Regula works seamlessly with that as well. So with that, I'm actually going to go ahead and actually, before I hand it off to Curtis, Sivia, did you have another question you wanted to ask?
Well, there is a question that came in from Tom Ruocco. Where is the source code for Regula? GitHub?
That's a great question. Yes, it is all live on GitHub. And we have a docs page that Curtis is going to show you all in a second.
Yeah, and I just shared the link in the chat as well.
I'm going to hand it over to Curtis, who's going to talk about how you can secure your infrastructure as code with Regula.
Hey, everybody. So I'll build on what Chris has explained, and we will dive into using Regula. So first off, to build on those questions and answer some of the questions about where you can learn more about Regula. So first off, there's regula.dev, which is our documentation website for Regula. So this is where I would point you if you want to get started with installing it, giving it a try. There is a getting started page, which shows you exactly how to install it. There's a native install option. So anybody that's using Homebrew, you can just brew install Regula. And you also have the option to use a Docker image. And that is available on Docker Hub here as Fugue/Regula. So there's a lot of ways you can get started with it really quickly. All right, so again, that's regula.dev for the documentation page. I am gonna share a different window now. So we're gonna jump into my VS Code window. So to kind of set the stage here a little bit, we're going to work with a cloud application we call Superstore, which is just an example of cloud application for us. It's deployed to AWS using both CloudFormation and Terraform. And it is all inside this one Git repository, just for an example. And let me show you what this looks like in its deployed form. So I'm going to share a different window actually. So this is the Fugue web console. And so this is doing runtime scans of our cloud accounts. We'll go in here into the Superstore environment in Fugue and go to the visualizer. So this is the deployed infrastructure for the Superstore application. Many of you may not have seen this before, but this basically visualizes all the resources in a cloud account, whether it's AWS, Azure, or GCP, and lets you see some of the relationships about how the resources connect to each other. So highlighted in the blue square here, blue rectangle, is our VPC network for the Superstore application. Some other resources in here include a load balancer, a couple of EC2 instances, and those EC2 instances communicate with the RDS database. So it's kind of a pretty typical set of resources you might have in an AWS account. There's also a handful of S3 buckets in here that are used by the application, and a CloudTrail trail that is tracking API events in the account. So this is kind of the set of infrastructure we're talking about. And as I mentioned, this is deployed and kind of known to be in a secure state. And so we're going to try to keep it that way as we work on the IC templates. All right. So with that in mind, and with that as the backdrop, I'll switch back to my VS Code window. All right, so this is all the code corresponding to that application. And we're going to talk about a couple different ways that we can add in IAC security checks into this, with the key idea being get developers feedback early in the development process and really have multiple layers of feedback so that they can both get feedback super early, potentially before they even make any commits, as well as get feedback in your CI/CD workflows. For example, a layer of testing there, and then a final layer of checks before a deployment actually occurs so that we catch any issues before they actually go out. So we're going to step through that here. I've got a Circle CI configuration in the Superstore account that sets this up. And to show you briefly what the Circle CI workflow looks like, I will go to that. So here in Circle CI is our standard workflow on the main branch in that repository. And we'll just talk through these several jobs that are in here. So first off, when a change is made on the main branch in the repository, we're going to run some CloudFormation linting to check for any basic syntax errors and so on in our CloudFormation templates. We're going to run Regula against all the IAC templates in the repo, and that will find any issues throughout the entire repository, whether it's Terraform, CloudFormation, or otherwise. If both of those pass, then we'll start the deployment. When the deployment finishes, we're actually going to trigger a Fugue runtime scan as well. And so you can kind of see here the multiple layers of checks happening, where we have checks in CI/CD before deploy, and then a runtime scan post-deployment to kind of refresh Fugue's understanding of what's actually deployed in the account. All right, sorry to keep switching back and forth on Windows, but all right, back to the VS Code window. Let me show you what Regula looks like for the developer. So I've got the Regula CLI installed, and so I can run Regula-H and get the basic usage information like you can with about any CLI. You can see we've got a number of subcommands in here. Most notably, Regula run is what you're going to use kind of on a daily basis. So that runs, you know, the default rule set against all the IAC templates in this directory and all the subdirectories. And by default, that outputs a JSON outputted report. And so you can see Regula produces a whole number of rule results, which is basically for each resource that it found in the repository, it's going to tell you its resource type, its resource ID, the file path to that resource, and then any rule results associated with that and whether they passed or failed. So the JSON output you can of course use in automated tools if you have it, or there's a number of human readable outputs too. So if we do regular run -h, you can kind of see the usage information there. You can see that you can work with different types of inputs, whether it's CloudFormation templates, Terraform HCL, or Terraform plans, or it can auto detect file types and work with whatever it finds. Similarly, there's different output formats, JSON, which you saw, and a number of others. Whole bunch of other flags here you can use to kind of customize the behavior to work for you, but pretty much the defaults work pretty well out of the box. And a key thing, like I said, is just running regular run checks your entire repository for all issues, which is super easy to do. All right, so that is the basics of Regula. Let's see here. So I'm going to do an example now of making a intentionally bad change and confirming that our CI/CD workflow catches that and prevents me from deploying.
Curtis, before you
Yeah.
transition, there's a question that maybe this might be a good spot to ask. Devaraj says, and I'm sorry if I mangled your name, can we add a policy to check if any S3 bucket is created without disabling public access or encryption turned on in Regula?
Absolutely, yes. I believe we have a built-in rule for that, and they are also easy to add. So absolutely is the answer. No. I know off the top of my head that there are a number of rules built into Regula that do S3 bucket checks, and I just forget if that one is in the currently open source set of rules. Thanks for the question. All right, so in Git, we're on a branch here, lunch, and I believe I have a pull request open on this branch already in GitHub. I'm gonna go ahead and make a change here, push to the branch, and then we're gonna see the CI/CD run. Close this. So our CloudFormation templates are under source infra for us here. And along the lines of S3 buckets, actually, I have some known good S3 buckets in here that do have bucket policies already set up, for example. Let's act like I'm a developer trying to quickly add a new bucket. So I do the basics, define the name, some tags, that's about it. And I just try to get this thing out there. But as you all might guess, there's a number of things that does not include, like the bucket policy. All right, so Git status shows we got a diff on that CloudFormation template. We will add it, we'll commit that, add it, S3 bucket, and we will push that. All right, we've pushed our change that includes that new S3 bucket, which has a number of deficiencies, including no bucket policy and no S3 public access block like you all just asked about. So let's switch to our CI/CD workflow and see what that does. We'll switch views to all branches. All right, so here's our running workflow. CloudFormation linting passed for that. So, that type of issue is beyond just a syntax error. So it makes sense that CloudFormation lint did not catch it. The Regula run workflow is running and about to wrap up. Looks like it called out 3 issues. And in fact, one of them might have been the issue that was asked about. So you get that feedback in the CI/CD workflow itself, of course, and that job failed. But what I also want to show you is that on the corresponding pull request, there is some feedback posted from Regula about specifically what the issues were. So this is kind of showing, for a given spot in a developer workflow, we've got multiple different ways that we can provide developers and the team quick feedback, both in the CI/CD tool itself in this view, but also directly on pull requests. And you could do the same type of pull request feedback in Bitbucket and others too, for example. To talk a little bit about the feedback here, you can see that the Regula report found 18 resources in a good configuration, but one resource had issues. And there were actually 3 different failing rule results for that one resource. It's an S3 bucket called app bucket. That's one we just added. And you get its file path, and you can see that there's several issues with it, 2 high severity, including the block public access issue and lack of server-side encryption. So this correctly caught us pretty early on. That could have prevented the deployment, for example, which is good. It would be easy to update this to actually block that pull request so that you can't merge it too. Right now, it's just posting a comment. So that's pretty good, right? But we can actually do better by giving even earlier feedback. All right, so back to, oops, sorry about that.
So Curtis, while you're going back, I'm taking advantage of any breath there. So
Yeah.
basically, the security check failed, and therefore Circle CI or Jenkins will halt the deployment. Got it. It was more of a comment to you. Is that correct?
Yep. Yeah, you got it. In that particular CI/CD workflow, it was just basically running tests against the branch. So in that specific instance, there wasn't a deployment plan. But if we went ahead and merged that pull request, it was going to trigger a deploy potentially, and that would have been blocked. Point being, there's kind of a few different ways to integrate it and lots of options so that you can implement what makes sense for your team. All right, so we introduced that bad bucket. I'm actually going to back out that change. So I'm going to comment that back out. I'm going to get my setup back in a good state. That S3 bucket. All right, we got that committed. Now I'm going to show you one other way that you can add in IAC security checks even earlier, so that before you even commit, you can get feedback about whether your IAC template changes are secure or not. And to do that, we're going to leverage something called Git pre-commit hooks. You may or may not have heard of these. Basically, it lets you run hooks or commands or scripts as part of the Git commit process. And this is, highly customizable, so you can do about anything. And we're going to use it to run Regula on the files that were changed and reject the commit if you are making a change that introduces security issues. All right, so to set up pre-commit hooks, you create this pre-commit config.yaml. And if anybody needs more information on this, we can share it out. But you create this YAML configuration file and identify the set of hooks you want to run. We're going to run some Python code formatting. We're going to run a CloudFormation linting step, like what you saw in the Circle CI setup. And we're going to run 2 different Regula hooks, one that's focused on CloudFormation, one that's focused on Terraform HCL. And you can see here each of the commands. So the idea here is if I change any of the YAML files in this repository, I'm going to run Regula against it. If I change any of the .tf files in this repository, I'm going to run Regula against those. And the pre-commit setup passes only the changed files to those, which is pretty handy. So you get pretty quick feedback on only what you changed here. So to enable that pre-commit hook, I'm just going to commit that change. So enable pre-commit hooks. All right. And now from this point on, we're giving developers even earlier feedback with those hooks. So for example, I'm going to go into the security infra subdirectory in here. This is where we have some some Terraform templates rather. And I'm going to make a change. You know, maybe we had a bad merge or something like that. And in that process, we've mistakenly removed an S3 bucket policy from our Terraform HCL. So that's an existing deployed bucket, and we're accidentally removing the bucket policy. You can see that that Terraform file is changed. Let's try to commit the change, and we'll see if my pre-commit hook setup is working right. Accidental Terraform change. All right, it looks like this did what we wanted. So I'll explain this output that you're seeing briefly. We attempted to do a commit. It ran all of our hooks. The first 3 of the hooks found that there were no files changed that were relevant for it, but we did change a .tf file. And so the Regula for Terraform HCL did run and it failed. So in this output, you can see that there were a number of okay results in the changes, but one of them was not okay. And that's missing a policy for a CloudTrail S3 bucket. And so that actually failed the git commit command. So you can see that I've got an exit code of 1, it didn't work. And if you do a git status, you can see that it's still staged, not committed. So we've prevented that change really early in the developer workflow so that they can't even introduce that problem for the rest of the team. So I will add that policy back. I will restage the file, and there's no change. So we're back to kind of a clean spot. So that's a quick demo of using pre-commit hooks for early feedback. Let's see, and we can really do the same thing with CloudFormation templates too. And kind of to talk about that, I'm gonna next briefly get into writing your own rules with Regula, so you can see a little bit about that. So you can see how you can customize Regula even more for your situation. Regula includes a number of built-in rules, and we're actually going to be open sourcing a lot more soon. But you can also kind of mix in your own rules with Regula's built-in, or only use your built-in rules. So you have a lot of options there. So in this setup, I've got this rules directory with some CloudFormation rules and some Terraform rules, really just one of each. So let's take a quick glance at those. Right. Rules. So for CloudFormation, this is an example of a simple rule in Regula. And when I say simple here, there's kind of 2 forms of Regula rules. One form, the simple form, works with one resource at a time. And it's really just optimized for that case so that you end up writing very little code, and it keeps it really streamlined. The fuller form of rules lets you do multiple resource checks. And so that's the 2 different forms. In this rule called approve-ami.rego, we give the rule a title. So in here, we're going to check for every EC2 launch template must specify an approved AMI. And so we've got a list of approved AMIs here. And basically this says for every CloudFormation input file we find, let's look for EC2 launch templates. And we're going to allow that launch template only if it's using an approved AMI as its image ID. So pretty straightforward there. I can show that specifically by running Regula run, and I'm going to say -u to say only run my user given rules. And I'm going to include the rules subdirectory, and I'm going to run with the tap output format. which is just a simple streamlined output format. All right, so you can see that we're running that rule. There's also this table output format, which is great and what I often use. It's just really hard to show on Zoom with sufficient zoom on Zoom. So I would encourage you to give that a try. And then switching over to more complex rules or more full-featured rules, this CloudTrail bucket policy, you actually saw this fail earlier. The idea here is we're doing a more sophisticated multi-resource check involving CloudTrail definitions, S3 buckets, and S3 bucket policies. And the point here is we want to make sure CloudTrail is logging to a bucket that has a policy on it. And there's a whole number of checks you can do along those lines. And if the policy is missing, that's going to be an error. If the bucket's missing, that's an error. So you can provide developers pretty early feedback along those lines. And you can see here, there's kind of 3 different cases that this rule handles. And so the rule defines a policy for each of these 3 cases, which is for each trail, if we can find its bucket and we can find its bucket policy, we're going to allow it. On the other hand, if we look for a trail, it's got a bucket, but it does not have a bucket policy, we're going to deny it and say, you're missing a bucket policy. And then the third case, oops, sorry about that. The third case is for each trail, if we can't even find the bucket for that trail, we're going to error out because it looks misconfigured. So that's kind of how you can use Regula for a more sophisticated multi-resource check. Hopefully that makes sense. And as I mentioned, you can kind of mix and match your own rules with Regula's built-in rules. And again, one of the things that Chris had mentioned earlier is a key thing with Fugue and Regula here is that in many cases, you can actually use the same Rego code here and the same rules at both IAC time, at design time, and on runtime scans of your resources. One other quick thing I'll talk to is we've put a lot of work into the automated testing aspect of Regula. There's so many resource types and so many different rules and different resource attributes. It's, it can be pretty intimidating and difficult to get right. So we put quite a lot of effort into this Regula test command and various other tools that help you basically create automated test cases for every rule you write so that you can prove they work before you actually use them with your team. So check out the Regula test command for that.
So one last thing that I thought I'd recap is bringing you all back to this diagram that describes the cloud development lifecycle. I just want to emphasize that what Curtis actually showed you was how by using Regula, an open source tool, and did show you as well some aspects of the Fugue SaaS platform in action, we cover all the different use cases that are illustrated at the bottom here. So as a developer, before any code is actually committed, Curtis showed how you can use Regula to check that. And then before code is actually merged into your main branch, he showed you how Regula could provide results directly in your GitHub console or in your Circle CI console as well. And how this could obviously work with pre-deployment checks as well. And he did show how you could then take that and see how things align at runtime. So I just wanted to reemphasize that is what Curtis showed us all today. Sivya, should I move to?
Well, I've got one question here. Swina asks, how is Regula licensed through Fugue?
So Regula, it's not licensed through Fugue. It's an open source project. It's through the it's open source licensed through Apache. So you can go ahead and get started at regula.dev with really no restrictions at all.
Perfect, thank you. And just to give you guys an idea as to what this poll revealed, about 33% of you spent less than 12 hours getting in IAC and compliance. 32 spent 10 to 50 hours, 50 to 100 hours is spent by 9% of you. 1% of you spends 100 to 500 hours, and more than 500 hours, 1%. And again, the 23% that don't use infrastructure as code.
Just to highlight where you can go to get started with some of the things that Curtis showed you. At the very top here, regula.dev, that's our documentation site for Regula. It'll take you 2 commands to get started with Homebrew, to get everything installed and going. There was a question earlier on just if you want to take a look at Regula, the open source project, and how it's structured, the rules, all that goodness. It's all on our GitHub site. The Docker image is on Docker Hub. And if you want to learn more about Open Policy Agent, which I mentioned is a project that Regula works with, openpolicyagent.org. Those are some great resources to get started. Of course, you can also check out fugue.co for a lot of resources on the Fugue SaaS security platform as well. Just addressing a question from Honyin Koch, asking if the Fugue solution only works on AWS or other multi-cloud platforms. So both the Regula open source project and the Fugue platform work across AWS, Azure, and Google Cloud. So we do support all of the big hyperscaler cloud providers there. Just to answer that question. And I believe there's one more question there. So if you saw it too.
I can field one other one. There's how is it different from Sentinel by HashiCorp? And I guess it's the ISE code compatibility with CloudFormation apart from Terraform. Yeah, so you touched on a couple aspects there. Regula, yeah, as you saw, works with not just Terraform, but CloudFormation as well, and very soon to be other input types as well. So for example, we may soon be adding checks on like Docker Compose files and Kubernetes Helm templates, for example. And you know, it's different in a number of other ways as well. The fact that we use Open Policy Agent and that open standard language is obviously a big one. And then, you know, I think you'll find that the Regula CLI and the Regula tooling is really excellent too. So give it a try and see what you think.
There's a question on the, there's a question on the developer license. So this is the developer license for the Fugue SaaS product. When we talk about 5 cloud environments, yes, that's 5 cloud accounts. So that's an AWS account or an Azure subscription or a Google project.
And also, yeah, and you talked about the Fugue free trial we offer. If you go to the website, you can get information on that as well. In your experience, I'm not sure who this is addressed to, but Arkady asks, in your experience, what is the distribution of using CloudFormation versus Terraform?
Yeah, that's a fun question. My impression, based on our customers and what I've seen out there in the community, is that Terraform seems more dominant. Probably more teams using it, but CloudFormation is quite heavily used too, of course. So in terms of customers we work with, it's a lot of folks using both, actually.
Thank you so much, all. And we hope to see you again at some of our other sessions. Curtis, Chris, thank you again for joining us and you know, just sharing your information and knowledge.
Yeah, thanks everybody for joining.